Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about what is a view, how to define a view, and when and where to use a view in SQL. What is the importance of view? What is a materialized view? How can we update a view in SQL? And finally, what is a transaction and how the transactions are controlled in SQL? First, we will discuss about views. Up here, we have discussed all the SQL queries, the updations, the database modifications, the creations of queries. These are all the logical model. But we know that all the users are not certain to be use all the logical model of a relation. They must be sometime restricted the use of a model. Say for an example, if I want that an instructor relation which is having four fields, the instructor ID, the name, department and salary. And I want that the student should fetch only the information about the instructor ID, name and department, but not the salary. So we can use this just like putting the query. So I'm using a query to select only the three of attributes from the instructor but not the salary. Now this is also in a logical level of conception. Now the physical level consists of storing up the data in the database. And there is another relation that is known as a virtual relation that conceptually exists but doesn't be stored in the actual database. So when I'm selecting this tree from the instructor table, it will give me a relation consisting of all the tuples or records from an instructor without the salary of the instructor. Now I want to create a virtual relation on this type of query other than being performed as a query. Now if I perform this query and I want this relation again once in another relation or by solving another query. So again I need to write this query or aliases with the table name which will be again stored inside the database. Now if I want a virtual relation that will conceptually store the result of a relation but not get any memory in the database, that is known as a virtual relation or view. So that is not a logical level, it is obviously a virtual conceptual level. So the views are performed to make use that a part of the attributes in a relations are kept for only the users that are meant for the logical level but not to see the entire logical level. So we will see that how to create views, how to deal with views and why views are used in SQL. So the basic syntax of creating a view is create view v as the query expression or the query I want to create as a view. So I will see that how to create this view on a basic and examples of queries and the relation we will store as a conceptual level. We can directly create a view from a table, directly copying up all the values as a view, but not that will be stored only for solving the queries. So this gives me that creating a view faculty same copied from the instructor relation, that is copying all the records or tuples from the instructor relation. But this is not matched with this one because I want the faculty list without the salary of the instructor, because the faculty view or the list will be given to the student for their use or reference which are not indented to see the salary of the instructor. So rather I can create the view as So now I have created successfully the faculty view, which is a part of the instructor relation containing all three of the attributes without the salary. So in this view, we will have all the records of the instructors that is present in the instructor relation, that the ID, name and department values of that relation. Now say I want to create a view that the physics department of fall semester on the year 2019 within a building and section number prescribed in it. So I have to go for the creating view just like this. So here I am creating a view PF19 as select the course ID, sec ID, building room number from the relation course and section. So we can even use a view or create a view using two or more relations by joining some predicates or conditions. So here are the conditions that the course of the course ID and the course ID of the section must match, while the department name being physics, same being fall, and the year being 2019. So in this way we can create a view using two or more relations too. So it is not about having a view only of a part of a relation, or it can be a resultant relations part of two or more joint relations. Now we will see that how to use views actually in the SQL queries. Now the PF19 that we have created a view, we can select that the building Watson named students I want to make a relation. So we can select it directly from the view, not the relation and having joined them inside a query. So we can do it like this. Now we are using the view actually that we have created for solving our query, not using the relation itself. Now we will use to create a view that will contain some aggregate functions, some predicates, as well as group by and having those one by one. Look for the key feature of the view here. As a relation that we are selecting, we can create also a view with a new attribute name other than the name specified in the relation. So we are making a depart name and dot sal as two of the attributes of the view. As select where the department name and sum salary, the aggregate function sum on the salary from the instructor, grouping it by the department name. So the department name I have renamed it as dept name and the sum salary as the dot sal. So two of the key features I have used here, that I have created a view with a new attribute name, as well as I have used an aggregate functions while creating a view. So these are being the more complexities that we face while creating a view, because in practical life we do not just create a view from a relation, rather than we have to create a view used for some predicates and on some conditions that to update our database. Now we can create a view even from a view itself. Say for the PF19, the view we have created, I want only the course ID and the building name from that view and create it as another view. So I am creating the view as So here we are using create view PF19WS, which is the new view, and we are selecting only the course ID and the room number from the view PF19 where the building is equals to Watson. So here are also two new key features introduced to you. That is, we can create a view from an existing view, and we can also use a predicate inside a view. So we are actually shorting down the view itself to make it more precise. Now we will talk about materialized views. Sometimes we want to store the view or the precise relation in the database for some special purpose. Now if I want to store a view inside a database, that is to be considered as a materialized view. And the materialized view has one important aspect, that if and only if the relation from which the view is getting derived has been transferred, updated, modified, deleted, then the materialized view should be kept reflected on the update. If the relation is updated, then the materialized view also have to be updated accordingly. So it is very much important to make up to date the materialized view by time for time. And processing of the materialized views updation is often known as materialized view maintenance. So it becomes absolutely necessary that sometimes we are storing a precise relation or a view that is only available conceptually to the user, but now it takes up a space in the database, and the view can be used as a normal relation for a precise one. Say we are actually having a big relation, also have a small precise part of this for some special uses. So that is why materialized view is becoming more important and popular among all the DBMS systems. Now that we have created a view and talked about the materialized view maintenance, so we need to learn about how to update a view. So updation of a view needs to update it according to the relation. And if I want to update only the view, we can do that also. It is not always necessary that upon modifying the database or the relation, the view will get updated. Often we can also update the view itself. Let us see how to update a view. Now we are inserting a value inside a view. Say we need to keep in mind that the view is always been a part of a relation. So previously we have created faculty view from a relation instructor, and can you remember that the instructor has got four attributes: the ID, name, department name, as well as the salary. Now, as a clerk can view the faculty view on his SQL queries, he can just write the insert into view name values of ID, name, and department on his side. But as view being a part of the relation, then when I try to insert a value in the view, it will try to insert it into the relation. So other than putting the value in the relation, we cannot actually insert some values in the view. So now when I want to update the view or insert a value in the view, this will cause an error because there is a missing field of salary here. So I need to keep all the attributes values just to put it here or it can be kept null. So either it will cause an error, or we can use it by appending a null value here to signify that there must be an attribute present which is not present in the view but in the relation. So that is one problem that we face while updating a view. There is another problem while modifying a view. Let us see the example first. Now look at that, I have created a view that is an IInfo or an instructor info that will consider the ID, name and building number of a department and the department-wise instructor relation. Now this considering instructor and department two relations. Now say I want to update or insert a value in the field of the view. Now we can see that I want to update the view as the ID, name and building number, which is absolutely looks fine on the created view of IInfo. But if the insertion statement will be executed, it will be generally and absolutely an error because the building construct doesn't have the ID name, as well as the instructor relation doesn't have the salary or the building name in it. So it is absolutely impossible to update this IInfo to actually update the relations instructor and department individually. So when a view is created by or among two or more relations, then by inserting only the values to the attributes of the view but not using the values in the department and the instructor or any of the relations, then it will become an error. See, if I also put null here, then it is not signifies that this null goes with the instructor or this null goes with the department values. So it becomes absolutely impossible. For these restrictions, the modifications to view has been restricted to some of the conditions. The conditions are if the clause or the query doesn't got any group by or having statement, if the select statement which we are using has got two or more relations, if the where statement is considering two or more run predicates, if the select statement has got distinct operation, if the where statement has got not null operation. Only in few of the conditions we can modify the view. Other than that, the modifications or updation on a view is restricted and not permitted by a user to perform. So let us see that how we can modify precisely and accurately on a view. See, here I want to create a view on the instructor which has only in the history department. So the history department instructors all records, I mentioned all the records, that is the tuples and the attributes will be the exact same that of the instructor. Only the history department names tuples will be there present in the view hinst. So the hinst contains all the attributes in the instructor, and now we can perform the insert, update and delete of a view just normal as a normal of the relation on the instructor. Now we will move to the next part of our discussion, that is a transaction. Now that we have discussed views, queries, modification of a database, we want to commit or we want to perform the queries or execute the queries based on some conditions. Say we cannot just arbitrarily put the queries like deleting an instructor name, putting a student marks, doing a telephone exchange values updation. We should put all the queries together to do a meaningful work. And when we are completing by executing a number of queries to do a meaningful work, that is known as a transaction. So transaction is basically a combination of the queries, related information, and doing a meaningful work. So to perform transaction, we need to put all the queries sequentially one by one. Now the main problem with transactions that we know I've discussed earlier, that the transaction must be atomic and consistent. So to follow two of these properties, that atomicity provides that the transaction must be performed at all or not at all. That if a transaction is started, it has to be finished. Otherwise, if it has started and not finished, it has not done and will not consider the transaction in parts. So we need to do it with the rollback and commit operation. When we commit a transaction, then we need to write. Now when I am committing something, that means I am saving till these queries and I have completed a transaction. That will also make a consistent data, because if a transaction has been committed, so all the affected result will be updated to the database, and I can see that the consistent data is there in the database. So the commit actually saves your work that a transaction has committed or completed. Now there is one more thing known as a save point. If I am making a save point on or part or some transactions, then I can see that I am saving till the part of the transaction. But that doesn't support the atomicity, so I will not consider save point as a part of the transaction. The next is a rollback. When I am committing or just writing down the instructions one by one by queries, and now I have performed rollback, so it will roll back till the last commit or till the first query of the transaction if it has not been committed. That means I am rolling it back or undoing all the queries that I have done. May I have done a wrong thing, or may I want to perform another operation just than the normal transaction. So I can perform the rollback on this situation. So the commit and rollback are two considered operations on the transactions, and save point is a part of the query in SQL but not as a transaction. Say I have save pointed some transactions or the queries and I have committed rollback after that, so it will be rolled back till the last save point, not the first query on the transaction. So that can make consistent data as well as a non-atomic part of the transaction. So generally we avoid save point in transactions. So that are all for the views and transactions in SQL. Thank you for watching this video. Stay tuned with Ikira and subscribe to Ikira.